Welcome to our ESG Auto Machine Learning Solution Marketing Accelerator demo in Alteryx. Environmental, Social, and Governance (ESG) is a framework used to assess an organization's business practices and performance on various sustainability and ethical issues. Our approach is very simple and based on 3 tenets. 1. Earn trust. 2. Be business outcomes focused. 3. Execute flawlessly. Welcome to our video on Alteryx Machine Learning-based predictive analysis of gas emission in automotive supply chain for ESG solutions. In the quest for an environmentally responsible supply chain, we present a groundbreaking solution, leveraging machine learning to predict gas emissions from cars based on their engine RPM using Alteryx Machine Learning. There are some use cases. Alteryx Machine Learning is here to help with a vast array of our gas emissions dataset, which includes VIN numbers, dates, times, locations, car make and model, gas type, concentration, company names, tier information, and most importantly, engine RPM. By analyzing the relationship between engine RPM and gas emissions, our predictive models can accurately forecast emission levels for individual vehicles across the entire supply chain. Whether it's monitoring gas emissions for regulatory compliance, optimizing fleet management, or ensuring sustainability goals are met, our ESG solution provides valuable insights into the environmental impact of the automotive industry. Armed with these predictions, businesses can make informed decisions to reduce emissions, improve efficiency, and contribute to a greener future. Join us as we revolutionize the automotive supply chain with Alteryx Machine Learning-powered ESG solutions. Step 1. Data preparation and exploration. We first need to create a new project in Alteryx Machine Learning and load the gas emissions dataset. On the problem setup screen, we need to on data profiling to get an understanding of the distribution of values in each column of the data and which data types AYXML has inferred, for example, numeric vs, categorical, etc. As our goal is to predict gas emissions from cars based on engine RPM, we will select concentration as the target variable for the modeling process. Alteryx Machine Learning recommends using a regression machine learning method as the target variable is numeric. We can study the data distribution of each column and notice that the columns named location, gas type, company name, and tier have only one unique value. We will drop these columns as they are not useful for machine learning. We can also observe that the data types of Alteryx Machine Learning inferred are categorical, date-time, text, and integer, as per the business context. Now we can go to step 2. Auto modeling. We now proceed to the auto modeling process by clicking Next. Alteryx Machine Learning then runs a suite of modeling algorithms to find the best one and provides results on the leaderboard. The elastic trees regressor model was the best performing based on the R²R2 metric. The elastic trees regressor model also performed well on most other regression-specific metrics like mean squared error, MSE, and explained variance. This increases this confidence that the model will perform well. Under the Feature Engineering tab, we proceed to the Primitives tab to see if there are potential signals in the data that might be uncovered through feature engineering. Feature engineering is the process of using domain knowledge to discover new features, characteristics, properties, attributes from raw data. The motivation is to use the new features to improve the quality of results from a machine learning process versus supplying only the raw data. Primitives are data operations that are used to create new features. We can view that the primitives are available. As we want to see how the raw data is modeled, we do not select any primitives and we come back to this panel later if the modeling results are not satisfactory to us. Under Advanced Model Settings, we can configure basic model training, advanced model training, and model evaluation if needed. Now we can go to Step 3, Evaluate Model. We then click Next to apply holdout data to see how the elastic trees regressor performs with it. We can observe that the performance of the model is same for both the holdout set versus that obtained against cross-validation data during the auto model step. The model performs well both during the cross-validation score and also during the holdout score. If we use this model with new data of a similar profile to the data the model was created with, the error range of the predictions should be consistent with what the metrics indicate. In feature importance, we can also see the factors that are influencing concentration. Unsurprisingly, RPM is seen as the most important feature, and it represents something that can impact the concentration level of the gas emission. Under Advanced Insights, we can see all the ranking metrics in detail in the Metrics option. Digging deeper, when we look at the partial dependence of our target column concentration with the other columns, we can see that for RPM it's 100 and all the remaining columns are not strong indicators, so we do not pay further consideration to them. We can also view partial dependence in plots. Under Simulations, we can configure all the what-if scenarios if needed. Next, Step 4, Export and Predict. Now we have a model that can be used to make predictions about the concentration of gas emissions based on engine RPM. We can download the results in the required format and use it accordingly. In conclusion, using gas emission dataset in Alteryx Machine Learning, we have observed that the higher the engine RPM, the stronger the concentration of the gas as it's linearly correlated to each other. Inquire about our complete Marketing Accelerators bundles. Follow us and like us on LinkedIn and visit our Marketing Accelerator page, www.fugetroncorp.com/marketingaccelerator. Thank you and see you soon for a live demo.